Okay, so this problem and this type of problem has to do with equilibrium constants in acids. So it's equilibrium constants in acids and bases. In this case, the equilibrium constant between an acid and a base is represented by an equation where you have the constant for the acid times the constant for the base is equal to the equilibrium constant for water. And that's, of course, if the solution is aqueous. And the reason this works is because when you have this constant, it represents the concentration of the acid, which is, you have the H plus ions in the water, and the concentration of the conjugate base over the concentration of the original acid. So this is represented by an equation that would look like this, like HA separates to form H plus A minus in water. Okay, and then for the base, it's a similar equation where you have OH minus and the A, which is the conjugate acid here, and then they're coming from HA, so the conjugate acid, and then they're coming from A minus, and that's represented by an equation that looks like this, where you have A minus plus H2O reacts to form HA and OH minus. And if you combine these two, if you multiply them by each other, they result in this, where this cancels with this, and this cancels with this. And essentially you have the H plus and the OH minus. And that's what this represents. And that's just the equilibrium of water. So that's H2O separating to form H plus and OH minus. So this is happening all the time in aqueous solutions in your glass of water. Okay, so that's why this equation works, is for all of these reasons. These separate equations that are happening inside water whenever there's an acidic or basic solution. Okay, so now that we've established this, we can look at the individual KAs and KBs. So the first one, I'm going to go ahead and convert them all to KA because it's easier to calculate the pH. Or actually, I'm going to calculate them to KB because we're looking for the highest pH. And a higher pH means that there is more base in the solution. So we can easily figure out which one has more base in it based on the highest KB. Okay, so the first one you have is, you have a Ka is equal to 4.0 times 10 to the negative 10th. Yes, and okay, so this is the Ka. So the Ka times the Kb is equal to Kw. So you have 4.0 times 10 to the negative 10th times Kb is equal to, and because, okay, and so that we know this constant is always equal to 1.0 times 10 to the negative 14th, and that this number looks familiar because it's related to the pH. you take the negative log of this, and that's how you get what the pH is. So these two numbers multiplied by each other always equal this number. Okay, so then you have 1.0 times 10 to the negative 14th. And so you divide this one by this one, you divide both sides by 4.0 times 10 to the negative 10th, and you can do basic algebra. And now you have the KB is equal to 2.5 times 10 to the negative 9th, right? Or 5th. I cannot do basic algebra, it turns out. And so you can calculate the other values. This is the value for A, and you follow the same protocol. B is already in the form of KB, so you know this one, its KB is equal to 1.8 times 10 to the negative 5th, which is a little bit less than this one. If you're having trouble thinking about it, just write it out in a non-scientific notation. 2, 3, 4, 5, 6, and 2, 5. Here you go. And this one is 1, 2, 3, 4, 5, 6, and 1, 8. And you have C. I already did the math, and it's the KB is equal to 5.6 times 10 to the negative 10th. And KB for D is equal to 3.1 times 10 to the negative 7th. And the KB for E is equal to 1.8 times 10 to the negative 7th. Okay, and so if you're looking at these numbers, and if you know that the KB is equal to the concentration of OH and the concentration of the conjugate acid, or forget the H. I don't have this one there. Okay, and over the base. So you know that this value is proportional to the amount of OH that's in the solution. So it's going to be the one of these that has the highest value for KB, and in this case that's A. You can see that pretty readily. Okay? If you have any more questions about this, don't hesitate to ask me.